Welcome back. So we've got a plan. We're going to get a sample of people living in Laverne, and we're going to use that sample to build a confidence interval like we've been doing to decide what the overall population has for eye colors. Now, one issue we had with this, what we called categorical data, was it's difficult to quantify. The way we get around this for this particular set of categorical data is you ascribe a 1 to the category you want to look at and zeros to everything else. So if you look at a lot of data sets that I've got up on the drive, 1 might go to male, 0 female, or 1 might go to pregnant, 0 not pregnant, something like that. It happens a lot. It's a very common tool in data analysis and statistics to do this. And also, it's going to help us nicely in determining populations or proportions for the population. But anyway, we need to get a sample. So I went and did this. Obviously, I didn't actually do this. For those of you not noticing, this is still in the middle of the COVID-19 outbreak and quarantine. So I made up numbers here. But I've got 13 people out of 20 with brown eyes, 5 people with blue, 1 with amber, 1 with green. And of course, I did not see any vampires. It was daylight. So that is what I had in my sample. So that means I would have 20 numbers, 13 ones, and 7 zeros. That's what I have there. Now, what to do with that sample? Well, if you want to have a 0% confidence level, you can say, yep, that's it. Got it in 1. That is the distribution of eye color in Laverne. If you want to be 0% confident, just do that. Call it a day. But we want to be 90% confident because samples are never perfect. Samples are random. We just can't do that. So to build a confidence interval, we're going to have to do something special. And that something special is called bootstrapping. We're going to make fake samples using our real sample. That's what bootstrapping is. The way you do it is with technology. You cannot do this by hand. And also, this is not something Desmos is going to be able to handle either. It's going to have to be some pretty heavy-handed computation work. Excel can do it with some coaxing. Statistical software like StatCrunch or StatDisk. Personally, though, R is the professional standard. So if you find yourself becoming a professional statistician, you might want to learn how to do it in R. But what you're going to do is make fake data, fake samples out of your real samples. We had 20 people in our sample, so we're going to make 20 more people in our next sample, picked randomly with replacement from the original sample. And then we do that about 1,000 times. More is better, but at least 1,000 times. So what I have up here, if you're looking, is my Excel data. I'm doing this in Excel. I don't want to teach you guys R because no. And I've got 13 brown-eyed people, 5 blue-eyed people, 1 amber, 1 green. And just like we discussed, I've got a whole lot of zeros for everything not brown and a whole lot of 1s for brown eyes. And then for the sample, and if you want to really zoom in on this command, you're more than welcome to. What I basically do is for each value in each sample, I make Excel pick a random number between 1 and 20. And then if it's 1, it'll pick this guy. If it's 5, it'll pick 1, 2, 3, 4, that guy. And if it's 7, it'll pick that guy. If it's 19, it'll pick that guy. And so it will do that for every spot of every sample. And that's because it's with replacement. So it's not like it can pick the same value twice. In fact, it can pick the same value every single time. And then we're going to do that, you guessed it, not once, not twice, but no, about 1,000 times. And Excel is okay with that. It's okay with doing tens of thousands of random data points. Hundreds of thousands, though, it starts to chug. And now I take all these samples, and I will take all my results, copy paste them over here so I'm consistent, and I will take all of the means of all of those proportions and build a normal curve. We'll look at this in the next video. See you then.